Okay, next up is factored form. So there's 3 different forms of quadratics that we're going to study, and each form makes different pieces of information really easy to get. So factored form, this is kind of a tricky one because when you factor a quadratic, it can look a little different, but we'll just start with this as a good example. Let's say we can get our quadratic factored so that any coefficient of x squared ends up out in front, and then we have x minus something, x minus something. And if, for example, s is negative, that would turn into x plus something, but just this basic idea of we have x plus or minus a number times x plus or minus a number. Okay, so again, exploring what happens, what does this value of a tell us? So here's a equals 1. As a gets closer to 0, it gets really flat. And as a gets bigger, it gets really steep. If a becomes negative, it flips upside down. Bigger negative makes it taller and skinnier. So a actually has the exact same meaning in factored form that it had in standard form. And if you think about that, if we foiled this ax squared or a times x minus s times x minus t out, we'd end up with an ax squared. So a really is still the exact same thing that it was in standard form. What gets interesting is what is this x minus s telling us? So if s is negative 2, that's what we're looking at right now. If s gets more negative, we're moving one part of the graph to the left. And if it gets less negative, this one's interesting, right at 3, and then bigger than 3, what we're doing is we're moving one of the x-intercepts. So what's valuable in factored form is it's really easy to spot what your x-intercepts are. So S tells us where one of the x-intercepts are. Right now, S is 0. We cross the axis at x equals 0. Ooh, let's play around with this. If we move it over, see if I can make it quite right. Maybe not quite. Pretend it's at 5. There we go. When we cross at negative 5, S is negative 5. Similarly with T is moving the other x-intercept. So if we make t closer to negative 5, the intercepts get close together. If both factors are x minus negative, so x plus 5 basically, then we only get one intercept. If the second one is smaller than negative 5, then the intercept goes the other direction. So factored form gives us really easy free information about where we cross the axis. And again, that's not something you necessarily just have to factor. Remember that if you want x-intercepts, you're going to let y equal 0. And if this is factored and equal to 0, that's why it's so easy to figure out the x-intercepts, because we would take it apart, we would set each factor equal to 0, and that would tell us where an intercept is. So always with quadratics, there's a relationship between a factor and an x-intercept, and that's what factored form is giving us. It is not immediately obvious just looking at the equation where the vertex will be, but remember, let's do this, make them easy numbers. If you know where your x-intercepts are, so now they're at negative 5 and 0, the vertex is always right in the middle. So if your quadratic is factorable, it should be fairly easy to get that x-intercept. Right smack in the middle of the two, because parabolas have this nice symmetry where the two halves match up perfectly. Vertex always has to be right in the middle of your x-intercepts. So factored form, it's easy to tell whether the graph opens up or down, whether it's skinny or fat, and it's easy to tell where the x-intercepts are. Thanks for watching.